Welcome, my dear friends. Today our topic is derivation of formula for refractive index of a prism. Prism is a transparent medium separated with surroundings. Out of three surfaces, two surfaces are reflecting surfaces. Those are in a rectangular shape. Those are also called as lateral surfaces, and the bases are in a triangle shape. Just we have to assume a triangle. That means here we have kept that prism and we have drawn the outer lines. So this is a outer line of the prism. That means it is a base, and these two are reflecting surfaces. These two are reflecting surfaces. So we have to put a name. That means for these vertices, we are naming those vertices as a PQR. PQR are the vertices. Okay. Before entering to that, just we should know the some basics. That means angle of incidence, angle of reflection, and normal. For example, if we draw any line perpendicular to the surface, this is called as normal. So this is a perpendicular line. This is a perpendicular line. This is we are calling as a normal. Our aim is we have to be derive the formula for that um, refractive index, and also in terms of angle of incidence and also the deviation. Regarding that one, we have to take a ray. This is a ray. The ray is incidenting on the particular point. The ray is called as incident ray. That means this is the incident ray. This is the incident ray. This incident ray making angle with the normal, that is called as angle of incidence. That one here where I am calling as I1. Okay, I1 is the angle of incidence. So this is the prism. That means it is a rarer medium, that means air, and it is the denser medium, that means glass. When the light rays are traveled from the rarer medium to the denser medium, at the place, that means at the interface, that interface I am calling as M, that light will bend. That means the ray travels like this and reaches another surface, opposite surface. That point I am calling as a N. There also should be take one more normal. Why? Because to calculate the angle. That means here it is also making some angle. Okay. And here it is emergent ray. That means that is ray, the ray coming from the medium, there is denser medium, that is called as emergent ray. The emergent ray is traveling along this direction, and it is also making some angle. Okay, now the angle between the plane surfaces, we are calling this as a angle of prism. That means where A is angle of prism, where A is angle of prism, and I1 is the angle of incidence. I1 is the angle of incidence, angle of incidence. And the ray which is reflected from the at the point M, that means at that point the ray the angle is angle of refraction. That is this one I am calling as R1. That means R1 equals to angle of refraction, angle of refraction. And it is making on some angle with another side, that is we are calling that one as a R2. That means angle of refraction. That means here this angle is angle of refraction. This angle is angle of refraction. This angle is angle of refraction, and this is the normal. Now just we have to be extend these rays. That means this is the ray we are extending like that, and this is the emergent ray we are extending like that. There, those two are where they are intersecting. There the angle which is equals to the, which is called as angle of deviation. The angle is called as angle of deviation. So this one we are called as a D. That one called as a, here R2 is the angle of refraction. That means R2 is angle of refraction. R2 is angle of refraction, and angle of refraction, and the angle made by the emergent ray with the normal, this is also a normal, that is we are calling as I2. Now our aim is D is also a, D is also a angle of deviation, angle of deviation. Now our aim is we have to derive the relation between angle of incidence and that means minimum angle of deviation. I will tell you what is minimum angle of deviation, and angle of incidence and angle of refraction. This is our aim. We have to derive the relation between those. Regarding that one, first we should take the d. What is the d? Is the angle. So here d is the exterior angle. So exterior angle, the formula is exterior angle which is equals to the sum of opposite internal angle, sum of opposite internal angles means, suppose if you have to calculate the d value, that is equals to angle of omn. So where this is the intersection point is omn, triangle omn plus triangle onm. So how we can calculate the omn and also the onm? That means here we have to calculate the angle omn by using this triangle omn. Actually what we know is pair of vertically opposite angles is equal. That means here this I1 which is equals to the triangle omn plus the angle of incidence here, that is equals to the angle omn plus r1. This and also that implies we can write angle omn equals to I1 minus r1. So similarly we can write for the I2, that means I2, for the I2, that is the opposite angle, that equals to onm plus onm plus r2, onm plus r2. That implies onm, angle onm equals to I2 minus r2, I2 minus r2. Now if we substitute these values omn and onm in above equation, therefore from above equations what we can write is d equals to triangle omn, that is I1 minus r1 and plus I2 minus R2. If we interchange those ones, that means I1 plus I2, from these two if we taken as a common, minus R1 plus R2, this is called as equation number 1. From triangle from triangle PMN from triangle PMN triangle PMN triangle PM angle of PM MNP, that means PMN, which is equals to the A plus angle PMN angle PMN plus angle MNP, which equals to 180 degrees. Why? Because sum of interior angles is equals to the 180 degrees according to that one. Angle A means A only. We have to calculate the PMN and MNP values by using those triangles. Okay, to calculate this PMN we have to consider this one. Suppose if we take this is total 180 degrees, that means it is a normal, that means 90 degrees for calculating the PMN. Okay, first we have to take, that is 90 degrees, 90 degrees plus angle PMN plus this angle, this is R1, that means this is R1 equals to 180 degrees. Actually this is called as equation number 2. So that implies angle PMN equals to, suppose if we take this 180 minus 90 minus R1, that implies what we can get is angle PMN equals to 180 minus 90 means 90 minus R1, 90 minus R1. We should be keep this in mind. Okay, in this equation we got the value, that is PMN, and we know the A, and we have to calculate the MNP. Same thing here also we have to apply. This is a 90 degrees, if we apply like that, what we can get is triangle MNP, which is equals to the 90 minus R2. 90 minus R2. Now we will substitute. Suppose if we substitute A plus 90 minus R1 plus 90 minus R2, which equals to 180 degrees. Where we have substituted in equation, so substituted in equation 2. Substitute in equation 2, we got this equation. Now that implies a equals to a plus 90 plus 90, that is 180 degrees, minus of, suppose if we taken as a common, r1 plus r2, that equals to 180 degrees. Suppose 180 degrees cancel, therefore a equals to r1 plus r2. This is equation number 3. Okay, from equations, what is the equation first one called? We didn't call any equation. Yes, we called from equation 1 and 2. What is the equation 1 here? I am showing here 1, that is d, that is equation 1 is d equals to I1 plus I2 minus of R1 plus R2, that means minus a. That implies d plus, suppose if we take this side, d plus a equals to I1 plus I2. This is the relation between the deviation, angle of deviation, angle of the prism, angle of incidence, and angle of emergence. This is the relation. Now our aim is to be derive the relation for the refractive index of the prism. Regarding that one, we call this equation as a 4. Now we have to apply Snell's law. Apply Snell's law at point. Snell's law at point M. At point M. So what is Snell's law? Snell's law is n1 sine angle of incidence equals to n2 sine of angle of reflection. So here we can observe n1 means refractive index of the n, that means medium, refractive index of the air, that is 1. Incidence, what is the angle of incidence here? Angle of incidence equals to I1. And n2 is the refractive index of the medium. Here refractive index of the prism I am saying n2. And sine r, that means angle of refraction, that is angle of refraction which is equals to the r equals to r1. We have to substitute in above equation. Substitute in Snell's law. Suppose if we substitute n1 means 1 into sine I1 equals to n2 means n sine of r, n into sine of r means r1. This is equation number 5. Once again we have to apply Snell's law at point n. So at point n, which one is first medium? That is the that means glass is a first medium, the refractive index n1. What is the angle of incidence there? That is r2. And coming from medium to the air, that means refractive index is n2 equals to 1, and the angle of incidence, that is the angle of refraction which is equals to the I2. Now we have to substitute in Snell's law. What is Snell's law? n1 sin I, that means n sin I sin r2, which is equals to n2 means 1 into sin of I2. This equation we are calling as a equation number 6. Now we have to know the angle of minimum deviation. So angle of minimum deviation means it is the smallest angle through which light is bent by an optical element. For example, in a prism, if angle of deviation is a minimum, is the incident ray and exiting ray from angles, equal angles. That means this one we are calling as a capital D, that means minimum angle of deviation. When we are calling that one whenever we are taking this QR and this MN are parallel, when MN is parallel to QR, then small d equals to capital D. That means that is the minimum deviation. Okay, for the minimum deviation at that position, the angle of incidence equals to the angle of emergence. So whenever angle of incidence is equals to the angle of emergence, automatically equation 4 becomes equation equation 4 becomes equation 4 becomes d plus a or a plus d equals to I1 plus I2. That means I1 plus I2 that equals to I1 plus I1. That implies a plus d equals to 2I1. That implies, suppose if we take I1, that is a plus d by 2. This is equation number 7. Okay, in this equation we got the I1 and we have to calculate the R1 value. Yes, we know that whenever angle of incidence is equals to the angle of emergence, automatically angle of refraction is also R1 is also equals to the R2. When R1 equals to R2, when R1 equals to R2, automatically equation 3 how we can write is a equals to R1 plus R2, that equals to R1 plus R1. That implies a equals to 2R1. That implies R1 equals to a by 2. This is equation number 8. So is this equation 7th equation, and 8th equation we have to substitute in equation 5. Substitute I1 and R1 values in equation 5. What is the equation 5? What is the equation 5 is there what we have written, that is a equation 5. Suppose if we substitute, automatically what we can get is sine of a plus d by sine of I1. Sine I1 equals to n sine R2. That is the equation 5. Sine a by 2. What is our aim? The refractive index of the prism. That means n equals to sine of a plus d by 2 by sine of a by 2. This is the formula for determination of refractive index, where a is the angle of prism, d is the minimum deviation, and n is the refractive index. Thank you.